Thank you for the reminder, Maria. Just about half of you have voted. If you haven't yet voted, let's take another 10 seconds to get your vote in. And what I see is very common that I see with students is that we have a split result for the answers on this polling question. I'm going to ask Grace, who's here helping us with some support today, to put us in groups, breakout rooms of 4 people. And in your breakout room, I'm going to give you, this is going to be fast. I'm only going to give you 4 minutes to talk about your answers and try to convince your people in your team and your group to vote the way you did. And then we'll come back and we'll vote again. Okay? Grace, are we ready?
Yep, all the rooms have been opened.
Okay. Green again. Can you see the PowerPoint again? I hope you were able to have a conversation. Let's revote now that you've had an opportunity to think about it a little bit more and share. Okay, I'm going to continue, reshare. All right, what's the answer now? Does it change your answer having talked with other people? So I can see it as a sidebar. I can see it. Your answers are changing. Okay, that's about half of you. Can I give you another 10 seconds? Everyone can vote. It seems like maybe there was some problem with audio in the breakout room. I'm sorry about that. Let's see if a couple more people can vote. I'm going to end the poll now and I'm going to show you the results. So when I do this in a classroom, I would do this a couple more iterations to see where students are. Here are the results that we had from the first poll. And about half of the people voted and the answers were trending towards the air. Let me show you the previous response was that the answers were trending towards minerals in the soil. So the one that I'm showing as a poll, this is what you just answered the second time. The one on the screen, it was the first time. This is pretty typical what happens in a classroom. And often I will give students one more opportunity to go into breakout rooms and I will have them talk about it again. And then we'll talk about some things around photosynthesis. And what we're doing with this one is that we're making thinking visible to the students. And this is one of those questions that I asked you at the beginning. How do you know what you know? And what evidence from your experience supports your choice or supports your decision? So one thing to think about as you're thinking about this type of question to make your thinking visible to students is that I ask them, okay, so if I go out and I burn wood, I have ashes in a campfire. Or I know from other classes that we've taken that there's increasing atmospheric carbon dioxide levels with decreasing forest. Or that I know as a tree grows, there's not a big hole in the ground next to the tree. So that helps me then maybe eliminate that it's not minerals from the soil. But if you don't think about this really often, if you don't think about how you think, it's hard to then understand it or making that thinking visible to students. So the correct answer, which you were trending that way as a group, the correct answer is photosynthesis. And the misconception with this is that students often think about the first part of photosynthesis. They think about creating oxygen and sugar, but they forget about respiration. And so they're not thinking about the differences in the processes that we have here, or what is it that actually makes a tree grow? So the photosynthesis is the carbon dioxide, the air. If you're not an ecologist or a biologist and haven't thought about this for a while, this can be really tricky to think about it. And that's like many of our students in our classrooms. Let me tell you just a little bit about the method to the polling that I was attempting to do here. And because the audio didn't work, it wasn't exactly what I would hope for in a typical, especially in-person classroom. These are 2 papers from a while ago now that looked at polling questions. The purple is a first question. And they had, and then the yellow is the second question, the first question after the students have talked, and then the gray is a second question that the students asked. So this is kind of the model that we just attempted to do, where I asked you the question, and then you went into a peer discussion mode, and I asked the same question again. And then there's what's called an isomorphic question, which would be this gray one, another question. So in this model, there's three different ways that we could look at this. We could have a peer discussion mode where, and you can see that students on that second question do quite a bit better than they did on the first question, just by talking to their classmates. In the instructor explain mode, this is rather than having conversation with your students, it would just be the explanation that I gave about photosynthesis. And then in the combination mode, where there's both students talking alone or thinking alone, students talking with their peers, and then instructors explaining, when you give students an isomorphic question, their answers, they've learned the concept and their answers improve. Okay, so that's the process of the polling discussion questions here. So let me ask you another question. I'm going to open the polling. During weight loss, where does the mass of body fat go? It's mostly breathed out. It's mostly excreted as solid waste. It's mostly excreted as liquid waste, and it's mostly converted to heat energy. Okay, I'm going to give you 10 more seconds, see if anyone else would like to join the voting. Okay, I'm going to end the poll and show you the results. So this is an isomorphic question, which means that this is the same question about the carbon dioxide and the air. This question is designed to pair with the oak tree growing. And this is a common misconception that students have, that it's converted to heat energy. The correct answer for this is that it's mostly breathed out as carbon dioxide. It's mostly the breakdown of sugars and carbon dioxide being breathed out. It doesn't make any sense. It makes sense that it would be converted to heat energy. And so this is a misconception that in a class we can spend time unpacking. Because when we're thinking about misconceptions, we're using our own life experience to try to make sense of the world around us. Okay, with that sample of a couple of clicker questions and some things about active learning, I'm going to turn this over to Maria. So I'm going to stop share. And I know I took more than my fair share of time, so forgive me. Take the full time that you have.
No worries. Thanks, Ellie. That was super interesting. I remember, I had a peek view on Ellie's slides in advance. And I apologize to that, but in my breakout room. but indeed, having it, having to think about that in action, in real time was really eye-opening. All right, let me now share my slides with you. All right, just confirming that all of you can see my slides.
Yes, looks great.
Okay, all right, good. So what I would like to talk about is, again, continue on the same idea of the same idea that Ellie has started, and look at it from a slightly different perspective. So how do you know when you've learned something of value? Right. So we've just figured out how you can test yourself whether you've learned something at all, but whether that what you've learned is really useful for you in the long term. How do you know what you need to learn? Right. So these are the questions that I've been asking myself, and I've been considering when teaching my courses. Just to remind you, I'm in a rather privileged situation of teaching very small classes, usually around 20, not more than 30 people. And that is very different from large classes, and probably many of the things that I will say might not apply to big classes. So I would like to give this disclaimer in the very beginning. When we define our courses' learning objectives we very often define it around mastery of factual information. However, apart from the factual information that students need to learn, we have for them long-term goals that are beyond our class and even beyond their university education. And very often, what we want for our students is for them not simply to know the facts, but be able to see those facts as concepts and be able to find such concepts in new situations, just like we had with the weight loss question. So how do we teach that, and how do we test that? For students, we know our material and we teach in it, but for students, new academic material very often looks like a thick forest of facts that they can get completely lost in. And we often see our role as lecturers as the people who will be creating a path in these woods and will be walking our students through it. However, there is a very important distinction here whether we will be walking our students through these paths and still showing them individual trees, or whether we will be taking them and zooming out into a bird's eye view of this forest and see the bigger picture of the forest rather than just the trees, and how this forest combines with the things that are around it. In this particular case, the beach and the ocean. But you see the connection, how these little facts that we are talking about, that of course they need to know in details, how they combine into bigger conceptual models, and how these conceptual models interrelate with other concepts, and what are their both hierarchical connections and interrelations. So these are the type of direction where I try to take my students as I'm teaching them physiology, cell biology, genetics courses. They will be applying these courses, this knowledge in the future in their research, and I want them to be able to use that information in an analytical manner. So the interconnection and the hierarchy are keywords for me. Okay. So our goal for the students really is conceptual learning, is an independent conceptual learning ability. That is, when they're confronted with a new source of information beyond our classroom in the future, they can still apply the same analytical skills, and they can still sift between important and non-important, between creating connections and creating conceptual ideas. And how do we get our students to there? So we often, the usual sort of classical expectation is that you provide students with some basic factual knowledge, then you provide them with detailed factual knowledge, and eventually they will figure it out, and it will all sort out in their head, and they will arrive to conceptual learning and to even independent analytical thinking. But very often, at least what I've noticed in my classes over the years, is that the reality is that, of course, they need some basic factual knowledge from which to start as a foundation. However, a detailed factual knowledge is really not bringing them any closer to conceptual learning and analytical thinking. So I needed to design some extra tools in order to bring them closer to what I wanted them to be able to do, is not get lost in the forest because of so many trees, but be able to see it from above. Or another way that another word that I like to use when describing this concept to my students is horizontal versus vertical learning strategies. If we're confronted with a pile of facts, of course we can learn them by spreading them horizontally as independent facts. And in fact, our students have a lot of experience with this method of learning, and this is called memorization. They have more than 12 years of experience of doing that. While they're proficient in memorization, it takes a lot of mental space, a lot of mental real estate to hold on so much information, and it's very difficult to retrieve it in its entirety. Or another way of another learning strategy will be creating vertical hierarchical connections between the facts, creating vertical towers, stacks of these facts. That type of of a learning strategy, very few of my students have had experience up to high school with, so they find it very difficult. It's a, you know, it's a new skill for them. It's like learning to ride a bicycle for the first time. However, once they get a grasp the idea and are able to do it, then storing the same amount of information requires significantly less mental real estate, and most importantly, it can be retrieved in its entirety. You know, bring in one fact immediately brings the entire string of the interconnected information. So how do we take students from a pile or horizontal learning strategy to stacks or vertical learning strategies? Of course, we can build stacks for them. We can present them with the concepts already. We can say, well, this is a concept. It starts from A, B, C, D, and then goes to Z, right? But it will be so much better if we can show them how to build such stacks by themselves so they can apply it to new information sources or new situations. So how to teach such conceptual analytical learning? First of all, it's important to demonstrate that, to model that for students in lectures, to focus on concepts, to make sure we separate all of the facts that are presented in a textbook unit, to separate the important from the details, and talk only about the important ones. So very often I say in class, this is a detail, so I will focus on that because that's important, because that's part of the concept which I want you to learn. Center in class discussions around how things happen and why they happen rather than what, just a statement of facts, rather how they're connected and why they're connected in such a way, and provide tasks on summary or application of concepts in class experience. So this, for example, is a small team project in one of the basic cell biology class on a basic genetics content, when they had to take several units of a textbook content, and they had to summarize it in a tiny little real estate of the blackboard. Only the most important, and they had to come up with a discussion question for each of these topics. Another way outside of class that we can introduce students to independent analysis and conceptual thinking and provide them with an exercise of that is give low stake chances to summarize content before class. Here, low stake and before class are the key words. And I believe that low stake, that is when it has a little weight in the final grade for the course. Well, if it doesn't have any weight in the final grade for the course, no one is going to do it, right? Let's be honest with ourselves. But if it has a lot of stake in the course grade, and this is a very new skill, it's going to be very stressful for students. So I like to give these assignments a 10, maximum of 20% final weight in the course. And the exercise here is to do this summary before the class. That is, before they come to class and we discuss this content with them in class, they have to have already read the textbook module, and they have to have scratched their heads and made the summaries beforehand, right? And these summaries can be scaffolded. And this is an idea that I got initially introduced by Ellie many years ago at one faculty development that she did at Nagoya University. When you provide students with questions or topics that are basically hinting them or directly stating for them the concepts that you want them to focus on from a particular textbook material. Or free summaries here will be when they're not provided with any scaffolding. They have the content in front of them and they have to figure out what here is important and what is not important. What is the concept that they need to put on their summary and what they can omit. And one type of a summary that I like to give to students is mind maps. Here is an example of a mind map made by a student of mine in an introductory human physiology course. And here just a very short description of the assignment as I give it to them. It has to be a summary of the chapter content, and it needs to be in a visual and hierarchical structure, the form of a mind map, and they have only one single page. Well, we use A4, but never mind, whatever's the size, one single page of space to fit the entire textbook chapter, which can be about 20 pages or more. And it has to be handwritten and hand-drawn. And what they know that they're graded on is really the hierarchy and an identification of the concepts. I'll get to this idea again in a minute. And here is just an example of a student who has no experience with conceptual thinking trying really hard, right? And you can see it's a beautiful mind map, right? And from all aspects, it has a lot of visuals. The instructions go significantly in more details. They know that they have to write diagrams. They know that they have to draw diagrams, and they have to reduce text to the most important keywords. But as you can see, there is too many details, too much text, right? This is a first-year university student in an introductory physiology course. This is a significantly better from a summarization point of view, from a conceptualization point of view, a mind map of the same course. An example of scaffolded summaries is what I call in my genetics course and an advanced human physiology course prep docs. The reason why I decided to give scaffolds in these summaries is because these are very fact-intense courses. These are extremely intimidating for students' courses with a lot of information to go through, and I have found that it's very difficult for them to figure it out on their own. So what I provide them is either questions or topics that hint them directly to the most important concepts that they need to focus on when they're reading, and they need to summarize. And they also have the freedom in this case. It doesn't have to be a mind map. They can summarize it in whatever creative way they want, as long as it's conceptual, it is hierarchical, and it's visual. And again, the purpose is to create a short version of the course content. And here is an example of a prep doc from an advanced human physiology course. You see how the information is organized with color codes and with diagrams. Here is another example, and as usual, just as I mentioned earlier, a most common comments that I have for students is that there are too many details and that the connections of the hierarchy are not that well seen. So these are the major skills that I'm trying for them to develop with these exercises. Another thing that we can do to introduce students to independent analysis and conceptual thinking is and give them again low stake chances to apply content that they've studied after class. So they've already done some summaries, they've already done some thinking before class, they've already discussed this content in class. And now after class as a second type of an assignment, they after a particular module as a second type of an assignment, they can do something with that content. And a very common way to do that is ask them to read a paper and summarize it in my case, in 5 slides, 10 minutes. Right? Especially if they read a paper for the first time, this is quite of a task, quite of an independent analysis task that they have to do. Or another one that I use in my advanced physiology course is what I call case studies. And in case studies, they need to select a disease of their choice that applies to the particular organ system that we're studying at the moment, and they need to identify what is the physiological concept that applies to this particular disease and how this normal physiology has changed in disease. Right? So in this case study, they need to skim through a lot of clinical information that they will find online. There will be a lot of symptoms identification, diagnosis, and any other clinical relevant information, and sift it out and figure out, okay, then what's the physiology? What from everything that we've studied as the physiology concepts in this module, which one of them would be applying to my particular disease that I've chosen? And after figuring this out, they need to describe this physiology separately from the pathophysiology, from the changes that have happened during disease. And And figuring this out, what is the physiology, and then separating it from the disease state is actually pretty difficult for students. So here is an example of a relatively good case study where the physiology is described, and you see the flow of connection. This happens first, and this happens second, and this happens third. But in reality, some of the elements were coming significantly early in the logic of things, which is in red my comment, and the pathophysiology as each of these elements has changed in the disease. Here is another less successful example, and just as a demonstration, what is the most difficult in this task for students is really separating the normal condition from the abnormal condition. Very often, just like in this case study, they put it together, so that's the norm, and then it changed like that, and then this is the norm, and then it changed. No, you have to put them separately, and that requires an extra effort of thinking. Here is another example. Again, identifying the concepts has been the difficult task here. Okay. So key elements that I have found in these particular examples that I have shown you in assignments of effective analytical thinking is, from my point of view, is limiting space. If you provide students with unlimited space, they tend to use unlimited space and put as many details as they can think of, simply because it's a very new thing for them to figure out what's important and what not. So limiting space to 1 page or say 5 slides, the examples that I often use. Then another important point is focus evaluation, not simply on the presence of facts, but on or identification or presence of key concepts, but also on the logical hierarchy of that information. How are these concepts interconnected? So what are your main branches in a mind map? What will be what will be the sub branches? And another thing that you might want to consider is assigning teamwork, not individual assignments. Right? Testing conceptual learning is very difficult in big classes. So as I said in the beginning, I will be approaching it from small classes. Short answer questions provide you more of an insight of how students think rather than multiple choice questions. And how and why questions and application questions are the key here. And also grading not only the information but the logic of organization is the key. Obviously, a major con for this strategy is that it's extremely time consuming, not only for the faculty but also for the students. Thank you. I think I went significantly over time, but I really wanted to show you the examples of my students. Thank you.
Thank you, Maria. We both went way over our time today, so I apologize that we're not going to give you quite as much time to talk in groups. Today, we are going to put you into smaller groups, and we have some questions. I just put them in the chat. I can also share them.
Oh, I will share them.
Okay, great. Thank you.
Mm-hmm. Okay.
So we're gonna, rather than 30 minutes, let's do 20 minutes. These are gonna be fairly good sized groups today. Have you introduce yourselves, say your name and your institution. If you're not able to turn on your camera or use your audio, if you could just type in the chat and let your teammates know that you're there and you're just not able to participate in the audio or visual. We'd like you to have 2 people, one to keep track of the time and one person who's willing to get the conversation going. Make sure that you're going through the topics. And we've got 3 conversation questions for you. How do you already use active learning? What's one topic that you use in lecture that students struggle with that could be designed as active learning? What are the benefits and challenges? And there's one more that I'm going to type into the chat, which is about what are the how important is conceptual learning for your topic or major, and what strategies do you use to encourage students to learn conceptually? All right, so 20 minutes. So timekeeper and a discussion leader. And Grace, I think I'm going to type this in, but we'll see who's faster, you or me. Grace, are you ready with the groups?
Mm-hmm.
Okay.
All right, opening now. And I'm going to go ahead and pause your recording.
Thank you. Al, are the breakout rooms closed? Are we all back?
They just all closed. Yep.
Okay, great. Well, it'd be lovely to have some reporting out from the groups from a key thought. I think we were in 3 groups. Somebody from group 1 like to share 1 or 2 key ideas from your group. Does anybody remember what group they were in? I was in group 2, but I don't know who was in group 1.
Maria, we're in group 1, I think.
Were we group 1?
You
Yeah.
were. I just looked. You were in group 1, Catherine and Maria. Yes.
Okay. Sorry, I really didn't look at the number.
Catherine, do you want to share something from your group?
Actually, Maria took wonderful notes.
I'm sorry.
I'll
Okay.
just leave it to her.
I was assigned with the note-taking task. All right. So what we talked about in our group was that in online environment, majority of our active learning strategies that we've used, whether that will be case studies or whether that will be just group discussions or whether that will be team project preparations, we were able to take them online. But one major issue with the online environments is when you're putting students into breakout rooms, you have no actual visual audio connection with them. So unless you go and check on them, unless you monitor especially if the group project extends for a long time, they might drift away to other things and lose their focus on the task that you have assigned. So monitoring breakout rooms we found to be essential.
Did you have a suggestion for monitoring breakout rooms?
Say that again?
Did you have suggestions for monitoring breakout rooms?
Going into rooms and monitoring them, and also having students, making sure that students are aware why they're in the class in the first place. So having them to make a written statement in the beginning of the class why they're here, and being reminded of that statement of why they're here. And another strategy would be for them to know what is the goal of that teamwork. So they have a presentation to do, for example, or they have a report at the end of the breakout room discussion in the main room as we are having now, right? So that is also a strong stimulus to actually keep engaging them on the task at hand. One active learning and conceptual learning strategy that many people in our room used were clinical cases. Or another one would be presentation or poster on a particular topic that is related to the course content, say environmental issues. One big issue, however, is with active learning and conceptual learning, especially with assignments, is that there is a lot of content that needs to be covered in a very short period of time, and such assignments take a lot of time already. So that becomes an issue. However, even though it takes a lot of time as building up a new skill, it might be one of the things that students report to be the most meaningful in their experience later on. Another thing that we talked about is adapting presentations, especially to team projects, and then presentations, especially to large classes of 300, 500 people. And one suggestion was peer-to-peer presentation and peer feedback. Not necessarily evaluation, but a feedback, and making sure that this feedback has a peer feedback structured, questions based on the grading rubric that will be used later, and using this peer feedback as a chance to improve before being graded, or might be even used for grading. So after teams worked, separating them in bigger groups and having them to present to one another and provide each other feedback. And this can be incorporated even in asynchronous classes by having teams record their presentation and other teams providing feedback also asynchronously. This is all from us.
Thank you so much. Great report out. I was going to ask Tracy, but she stepped out. Dan, are you still here? Would you be able to report back for our group?
Okay, sure. So our group talked about the questions. So for the topics or lectures about student struggle, the first question is, how do you already use active learning? So same as Maria's group, our group also have case studies like that and group discussions. And yeah, and for on topics that the students struggle with that could be designed into active learning. So in our there is a lot of challenges also, no, in um, in this for the students. So one example could be ethical issues in research, and one of our group members shared about sugar manufacturing struggles, scenario for this. And then challenges. So challenges, I think same with everybody. So internet connection is a challenge. And then we think that for online active learning, there's also a less personal engagement for the students. And for how important is the conceptual learning. So we see that the conceptual learning is very important, especially for building scenarios on the issues of different topics or subjects that we are teaching. Yeah. So I think that's some of the notes that I've taken. Thank you.
Thank you, Dan, so much. The third group, is there anything new that you would like to add to our report out here? Group 3 have a reporter. This is Amor, Annie, Concepcion, Arlinda, Fritzy, Jose, and Veronica. Is anyone able to share out? Arlinda, are you able to? Or anyone else from that group?
Sorry, I just came back from a toilet break.
Oh, I'm sorry, I put you on the spot.
And I heard my name.
Yeah. I was wondering if you'd be willing to report out anything from your group. One highlight from your group, from your conversation.
Let me see. Well, we had a good time sharing our experiences about active learning, the various strategies that we do. I think most of us do avoid individual work and do teamwork, and we also use breakout sessions. And there was one nice thing that was shared earlier by Annie, and that was like having teams come together before, like a few minutes, like did you say 10 minutes? I forgot, like minutes before the class, so that there's like a warm up sort of discussion about what the topic will be, and that it's giving them time to how's this it's just like sharing among them, and so that when they come to class, they have like something in mind already to share, something that was something I thought I might want to do in the future, like that sort of strategy of warming up before a class. I think it was Concepcion who also gave a nice sharing about because she teaches Christianity and in the contemporary world, something like that. Maybe Concepcion, you might want to share how you do it, because it's really better coming out from the horse's mouth.
Thank you, Erlinda. So yes, you got the name of the course correct. So of course, the challenge for a course such as this is to make ancient writings and ancient, thoughts more relatable, more palatable to our students. I mentioned also during our discussion that, at least in the Philippines, were encouraged to engage in asynchronous learning more than synchronous learning because of how bad the internet is. So at least, and I told them, I'm not so sure if what I'm doing is active learning, but I learned so much from the presentation a while ago. What probably I think might be similar to that is when I give students material, in the asynchronous session. So I give them material, I ask them questions, I ask them to post discussions where they talk amongst themselves online. When I meet them once a week, I post highlights of phrases or sentences that they got, spot on. And then I also highlight, of course, anonymously, what was wrong. And so when we do meet synchronously, it's not so much a lecture kind of session, but it's more of assessment, showing each other what they presented. So that sort of simulates the class. It sort of replicates the face-to-face learning because, you hear others and then, but in this case, I'm sort of just the vehicle for them to learn what each of them presented and what the connections are and what mostly was done wrong or was done right. And then in a way, you also have a vision of where to bring them to at the end of the course. So I teach them first Christian humanism, then Siderius Erasmus, the concepts, the writings he's given, and then sort of with the goal of making them understand the spirit of ecumenism, for instance, at present. So just something more, that's something just more specific to what I do. Thank you for this opportunity.
That's great. Thank you for sharing that. The multiple opportunities that students have to engage. That's wonderful. Great. Well, I have one last question for you in the chat that we came up with, which is, what is one idea from today that you would like to try out in one of your courses? We've heard a lot of ideas, both in the presentations and in the small groups and just now. So what's one idea you would like to try out?
Ellie, I think I'd like to try out the mapping, the one that Maria presented. I'm trying to, because I have an upcoming case study, and she did it, case study and mapping. So I might want to do it. My case study, I teach organizational behavior, and I have a case study on motivation. So I think I'll break away from the traditional case study that they analyze and then write what their thoughts about it. I might want to do a mapping for that.
Great.
Thank you, Maria, for the idea.
Great. Well, I'm seeing the
Thank you.
mapping. Many people have said the mapping in the chat and polling software and the vertical stacking concept with the Lego imagery. Really like that kind of the whole, can you take the whole stack and move it over? Great scaffolded summaries. Annie's thinking about misconceptions, peer feedback. Great. What I love about getting ideas from other people is I can go and I can try one thing out and then I can build on it and expand it. Maria mentioned that I did a workshop at Nagoya and we were just remembering that it was 8 years ago this week when we first met. And that was just a germ of an idea. So everything that Maria showed her is just that germ of an idea that she just blossomed and made it fit to your course and your content and your students. And I think that that's what can happen here. We're just planting seeds. Acorns, maybe. Great.
Yes, acorns.
Acorns. Thank you so much. We'll be back in a month and I can put that up. So the next session is on April 26th and 27th. Oh, my version here says TBD. It's not TBD. It's Claudia Tobar from the University of San Francisco de Quito in Ecuador, and we're going to talk about the imperative for collaboration during COVID in higher education. We heard little bits about collaboration today, so that'll come back. And as Melissa mentioned, we have another series that will go into May and June, and that will be on the website soon, and we'll make sure to email all of you so that you can sign up. We really enjoyed our time with you. So thank you so much for coming and sharing your expertise with us too.
Thank you to both of you, Ellie and Maria. That was wonderful.
Thank you,
Thank you.
Melissa.
Okay, take care.
Thank you. Goodbye.
Yeah, bye.
Good morning, good evening.
Bye.